So now we'll see the problem. In this problem, we'll try to calculate the frequency response of the given system. Okay, so we know that h of z for a discrete time system. For a discrete time system, h of z defines the frequency domain nature. Here in this, if we substitute z equal to e power j omega, then we'll be getting the frequency response. Okay, just replace wherever z is there with the e power j omega, then we'll get z transform. Sorry, we'll get the frequency response. That means what I'm telling, entire problem we can operate in z domain. Then finally we can substitute z equal to e power j omega. Okay, so that we can identify h of e power j omega, or otherwise directly you can also find out h of e power j omega with a discrete DTFT, okay, discrete time Fourier transform. But what is the condition? If you want to apply the discrete time Fourier transform directly, definitely the system has to be stable. That also they mentioned here, the given system is stable, okay, causal and stable. So either you can operate with DTFT or with Z transform. Once if you operate with Z transform, finally don't forget to put Z equal to e power j omega, just replace everything with the Z equal to e power j omega. So now we'll try to proceed directly with this format with DTFT. Okay, so now for this difference equation, we'll apply the DTFT on both sides. Okay, then finally we have to find out what is h of n. Once if we calculate what is h of e power j omega, then we have to calculate what is h of n. Again, yeah, there is no confusion. The given system is causal and also stable. Okay, again we know that in case of DTFT, we will not worry about the concept of ROC. The concept of ROC comes into the picture in the Z transform, and also they given the regular condition that is causal as well as stable. So we don't need to worry about the concept of ROC and all here. Okay, so just take the difference equation y of n minus 1 by 6 y of n minus 1 minus 1 by 6 y of n minus 2 so y2 is equal to x of n. Take DTFT on both sides. Take DTFT, apply the discrete time Fourier transform, that is y of e power j omega minus 1 by 6. Here shift is there, so e power minus j omega y of e power j omega minus 1 by 6 e power minus 2j omega y of e power j omega is equal to x of e power j omega. Just take y of e power j omega separately. We'll be getting 1 minus 1 by 6 e power minus j omega minus 1 by 6 e power minus 2j omega is equal to x of e power j omega. So then y of e power j omega divided by x of e power j omega is equal to h of e power j omega, that is equal to 1 by 1 minus 1 by 6 e power minus j omega minus 1 by 6 e power minus 2j omega. Just find out the factor for this, that is 1 minus 1 by 2 e power minus j omega into 1 plus 1 by 3 e power minus j omega. Just make sure that once if you multiply, you are getting this term. Okay. So finally, we are having h of e power j omega. Okay, h of e power j omega that is 1 by 1 by 1 minus 2 e power minus j omega 1 plus 1 by 3 e power minus j omega. Okay, if you write it in the z domain, you'll observe that 1 by 1 minus 1 by 2 z inverse. Again 1 plus 1 by 3 z inverse. Now what I'm going to do, just I'm going to operate with the negative power. So far we have been operating with the positive power. That's why we'll be taking some term from here to the downside. But now we are going to operate with the negative power. So no need to take any term downside. Okay, directly we can apply the partial fraction technique. Okay, so is a by 1 minus 1 by 2 e power minus j omega plus b by 1 plus 1 by 3 e power minus j omega. Okay, so again, what is the value of a? Okay, just apply the partial fraction technique. Okay, so now we'll try this because it is looking a little bit difficult. Okay, now let's see. Again, we know that shortcut. Okay, at this pole. Okay, whenever we concentrate on this pole, what is the value of e power j omega? If you concentrate on this pole, 1 minus 1 by 2 e power minus j omega is equal to 0. What is the value of e power minus j omega? E power minus j omega is equal to 1 by 2. That value is substitute here. Okay, so that means what you will be getting, you'll be getting 1 by 1 plus 1 into 1 by 2, that is equal to 1 by 1 plus 1 by 6. Okay, that is 1 by 7 by 6, finally 6 by 7. So okay, I think we made a mistake here. Okay, see here, from this step, okay, we'll not get 1 by 2, we'll actually get 2. Okay, so now we made some mistake. This is 2. Okay, this is 2. That means these are all wrong. Just calculate now. Okay, so e power minus j omega is 2. Just you substitute that value here. That is 1 plus 2 by 3. So 5 by 3. That means 3 by 5. So what is the value of a? That is 3 by 5 divided by 1 minus 1 by 2 e power minus j omega. Similarly, at these poles, what is the value of this? Just you calculate. Okay, you will be getting minus 5 by 6. Okay, the value of b is minus 5 by 6. Then 1 plus 1 by 3 e power minus j omega. Okay, just now let's recall the discrete time Fourier transform formula, basic formula for a moment. We know that whenever a power n, u of n is there, okay, what is the formula? 1 by 1 minus a e power minus j omega. Okay, then if you apply that formula here, okay, anyway 3 by 5 is a constant that you can write it separately. So from this step, you will be getting 1 by 2, okay, in the reverse, that is 1 by 2 whole power n, u of n. In here minus 5 by 6, here it is plus 1 by 3, so that you will be getting minus 1 by 3 here. So minus 1 by 3 whole power n u of n. Okay, so this is h of n. Okay, this is h of e power j omega. Okay, this h of e power j omega is the frequency response. Okay, frequency response. That means if you substitute omega value, you'll be getting what is the magnitude. Just if we take the inverse dt of t, you will be getting the h of n in time domain. That means impulse response. Okay. Next question. Check whether following system is causal or not. Check whether following system is causal or not. H of z is equal to 1 by minus 1 by 2 z inverse plus 1 minus 2 z inverse. In ROC, they given mod z greater than 2. Okay, whether the given system is causal or not. Okay, so here the pole for the first term, the pole is at 1 by 2. For the second term, the pole is at 2. Okay, so if you draw the circle again, this is the reference circle. Again, inside one circle is that is minus 1 by 2, that is 0.5. Again, one more circle at 2. Okay, with respect to circle 2 with radius 2, the ROC, they given mod is at greater than 2. Okay, that means ROC is going outside. Okay, if the ROC goes outside, definitely this is causal. Okay, definitely this is causal. So the given system is causal. Okay, the given system is causal. If it is causal, what is the transfer function? That is 1 by 2 whole power n un minus, sorry, plus 2 power n un. Okay, both are right-sided signal because it is causal. Both are right-sided. Okay, both the terms are right-sided because this is the causal system. Okay, thank you.